In this video, I'm going to go over how to factor a polynomial by grouping your terms. So you're going to have to be pretty familiar with how to take out a greatest common factor from two or more terms in order to succeed when you're grouping. So to figure out whether or not I'm going to be grouping my terms, I look for two things. I look to see if I have either 4 terms or 6 terms. Because if I have 3 terms, I could probably use the AC method, or if I have 2 terms, it's probably going to be difference of 2 squares, or maybe a sum or difference of cubes. So let's say I've got this polynomial right here. If I look at the first 2 terms, and I look at the next 2 terms, I notice that there's a greatest common factor in each pair. So let's take the first two, 2x cubed minus 4x squared. The 2 and the 4 are both divisible by 2, so I could pull that out. And the most variables they have in common is that x squared. So I would have to have an x as the first term in the set of parentheses, and a minus 2 right next to it. So that if I distributed that 2x squared, I would end up back with the 2x cubed and the minus 4x squared. Between the 5x and the 10 doesn't have any variables with it, but they're both divisible by 5, so I could pull out a 5 from both of them to leave myself with x minus 2. So the thing you need to notice with factor by grouping is that the term in the parentheses should always be the same, so that I could factor out the GCF here of x minus 2, because both the 2x squared and the 5 have that in common. I write a second set of parentheses, and I leave my leftovers. 2x squared plus 5. I'm just getting those from what was in front of those sets of parentheses. Sometimes you'll have to factor further, but it doesn't look like there's anything I can do in either of these sets of parentheses. So the reason algebraically why this makes sense is because let's say I didn't have that 5 there, and I just had 2x squared times x minus 2. Well, that's what I have right here as my first thing in this polynomial. If I just had the 5, I'd be taking that 5 and distributing it to the minus 2 and to the x, which is exactly what I have in the back half of the polynomial. So you could memorize this process if you want, but it's easier to think about the concept so that if you're trying to pick which way to factor, it's a little bit easier to decipher. What I would say is one word of warning. For some of these examples, you might have to rearrange your terms first before it's obvious that there's a GCF in the first 2 and a GCF in the second 2. So that's if you have 4 terms. If for some reason you have 6 terms like in both of these examples, you need to think a little bit harder. You'll never have to rearrange them like we did in the last example, but you might have to try a couple of things before you're able to successfully group. So let's take this first example. I'm going to group these first 2 terms, the next 2, and the last 2. I'm still going to pull out a greatest common factor, so between x to the 4th and 16x squared, I could pull out an x squared to leave me with x squared minus 16. For these next 2 terms, between the 4 and the 64, I could pull out a 4, and between x cubed and x, I could pull out an x. I'd just be left with x squared, and then when I divide 64 by 4, I get 16 again, which is good for factor by grouping because I'm supposed to get the same thing in the parentheses. So when I end up doing that a 3rd time here, if I pull out a 3 between the 3 and the 48, I'm left with just x squared, and negative 48 divided by 3 gets me that negative 16. So I'm going to do that same trick, where I pull out the greatest common factor, or just what I have in that set of parentheses each time, and multiply by what I have left over. I've got this x squared, a positive 4x, and a positive 3. So those would go in the parenthesis right next to it. Now you should notice here that we haven't factored completely yet. This right here is a difference of 2 squares, and this right here is a regular trinomial. So after you're done factor by grouping, there will usually be another step that you have to go through to get it to be factored completely. If we try to use that same logic with this second example, though, we run into an issue. where between x to the fourth and minus 12x cubed and 35 and just minus x squared, I can already see if I try to pull something out of the first two and the next two, I won't be able to get the same thing in those parentheses that I need for factor by grouping. So I'm going to try a different strategy. Rather than grouping by twos, I'm going to group three terms together here. So between x to the fourth and minus 12x cubed and 35x squared, looks like I could only pull out an x squared as a greatest common factor, to be left with x squared minus 12x plus 35. If I'm looking at these next three terms, it doesn't really look like there's anything I could pull out from them. But I know that I want to get x squared minus 12x plus 35 that I'm multiplying it to, and it looks like I almost already have that, so I'm just going to factor out a minus 1. What that is going to do is going to change the signs of everything in those parentheses, so that if I were to distribute that minus 1, it would give me a minus x squared, a positive 12x, and a minus 35. So if you look at that, now I have the same trinomial in those parentheses. So I'm going to do the same thing, where I factor out that trinomial as a GCF, and I write what I have left over, an x squared and a minus 1. So again, you could go a little bit further here, because you do in fact have a difference of two squares here, and another trinomial. So just be careful and make sure you're asking yourself if you're going all the way if you're asked to factor completely.